Yeah, good morning from trees. Welcome to today's lesson, this time for chemistry. And today, if you look at the whiteboard, there is a flow chart. We are going to look at the large scale manufacture of sulfuric acid. We looked at the compounds of sulfur, some of them, whereby we looked at how we can manufacture sulfur oxide gas and the sulfur 6 oxide gas in the laboratory. And I just want to remind you that the most important thing is to mark the reagents. Like now, when it comes to preparation of sulfur 6 oxide gas, we normally react sulfur 4 oxide and oxygen for us to produce sulfur 6 oxide gas. But before reacting sulfur 4 oxide gas, it must be dried. And the drying agent we normally use is concentrated sulfuric 6 acid. So it is just a one-step process. We have our sulfur 6 oxide gas. Now come to this process, large-scale manufacture of sulfuric 6 acid. For us to manufacture this acid, we use a process known as contact process. Why is this process known as contact process? We normally use a catalyst, which is in solid form, and the name of the catalyst we normally use is known as vanadium 5 oxide. So the very first chemical reaction which occurs between the gaseous mixtures, that is sulfur 4 oxide gas and oxygen, are normally in contact with this catalyst. So that contact between the gaseous mixture and the catalyst, that is vanadium 5 oxide, gives us the name of the process, contact process. If you look at this flow chart, it's a guide on how the process can be carried out. In the first step, we have sulfur, which is going to react with air. So in air, it is going to react with oxygen for us to produce sulfur 4 oxide gas. So in the burner, as the first chamber, sulfur is going to burn in air. In simple terms, it is going to react with oxygen to give us sulfur 4 oxide gas. After we have obtained the sulfur 4 oxide gas, we move to the cleaner, or you can call it a dryer, or a purifier in some books. So the gas in the purifier will be purified for us to remove the impurities. The most impurities we normally encounter in that gas are the dust particles, and for us to remove those impurities, we pass the gas through the cleaner or the purifier. Why should we purify sulfur 4 oxide gas? For us to remove the impurities, we increase the efficiency of the catalyst, and we increase the yield of sulfuric 6 acid. Then from the dryer, we move to the heat exchanger, whereby the optimum temperature for the gaseous mixtures to react is going to be set. Then after the heat exchanger, we move to the catalytic chamber. So in this catalytic chamber is where we have sulfur 4 oxide gas reacting with oxygen. I can write the equation here, sulfur 4 oxide gas and oxygen gas to give us sulfur 6 oxide gas. At that point, it is an equilibrium reaction, and we normally use a catalyst known as vanadium 5 oxide. If you cannot use vanadium 5 oxide, you can use platinized asbestos. But the most preferred is vanadium 5 oxide as the catalyst. Why do we prefer vanadium 5 oxide? It's very cheap, unlike to platinized asbestos, which is very, very expensive. Another reason, vanadium 5 oxide is readily available. You can easily access it. The next step after obtaining sulfur 6 oxide gas, you go back to the heat exchanger, as you can see by the show of the arrow. And at the heat exchanger, the gaseous mixtures are going to be cooled. This is a section whereby temperature is being regulated. Then we already have sulfur 6 oxide being taken to the absorption tower. In the absorption tower, we are going to react the sulfur 6 oxide with concentrated sulfuric 6 acid for us to obtain a compound known as oleum. we have our oleum. After obtaining oleum, we move it to the dilution chamber, whereby we are going to react it with water for us to obtain our sulfuric 6 acid. Yeah, so at that point, after you have diluted the oleum, we have obtained our sulfuric 6 acid. Maybe if I can inquire from you students, if you have any question, any inquiry before we end the lesson, it is your time. And if there is no any question, we are going to stop there for today until we meet again in our next lesson. Thank you for listening.